Hello, good morning. My name is George. I'm a mentor for the GAS program, Google Africa Developer Scholarship 2020. Today I'll be sharing with us, I'll be putting us running one of the quick lab sessions, Kubernetes Basics 1.6. Show you how to navigate your way around the quick labs console or page and share with you basic understanding of Kubernetes. Okay, first of all, before you start any lab, you need to read through. Of course, this is the overview. You read through it, and it tells you a bit of what you need to know before you start, and then tell you also the objective of the lab. Okay, so use Kubernetes engine and its Kubernetes API to deploy, manage, and upgrade applications. Use an example application called app to complete the labs. Of course, this information is about the lab. Then the setup, of course, we're told to always use an incognito window. And then we should ensure we use the credentials that we provided by Quick Labs and not our own Gmail accounts to access the G Cloud console when it is launched. Okay, so of course, that's for step one of preparation. Setup. Step two, enable Kubernetes Engine API and Container Registry APIs, because these are the APIs that will be used alongside with this lab. Okay, of course, we activate the shell and use that to run some commands to carry out our task. And then we clone, of course, we clone the Git, the repository using Git command, and then we walk through the order. So let's begin. Let's begin. Okay, first of all, you click on this. While they're setting up. Okay. All right. Okay. All right. So it's provisioning. So we'll wait for it to get set up, and then once that is done, we will begin. Okay, it's done. Click on Open Console. Click here. Click the username. Place that in here. Hit enter. The password. Put that in here. Enter. Okay, we accept the terms. And then, of course, when we get to this page, you don't need to update this because this isn't your account. It's a temporary account set up by Quick Labs to help you carry out the labs. So you simply click on confirm and it moves you to the next window. Okay, give it a minute or so, should be ready. Okay, so that's coming up. So what's the first thing we're supposed to do? Or the second thing we were supposed to do? We need to, on the navigation menu, click on the hamburger icon and then click API and services. Search for these two APIs and make sure they're enabled. Okay, so one last thing to click on before we start. Okay, click on this. This isn't necessary. It shouldn't be done. This account doesn't belong to you, so you don't need to update any emails. Okay, so we click here. We click here, we go down to, okay, come up to API and services, click on the library. Select library there. We're going to search through. So what are we looking for? We're looking for the Kubernetes API. Let us copy that one. Place it in here. Hit enter. Okay, so that's it. Okay, while that is warming up. Let's select the next one. Okay, so it's been enabled. All right, so go back to the library, get rid of this and paste that of the container, Google Container Registry. Let's see if that also has been enabled. Okay, it has been enabled, so we don't need to do anything there. Okay, now let's activate the Cloud Shell. Okay, activate that. You click on continue. While that is setting up, let's run through. Okay. Okay, now take a look at this. You should see something of this nature. I think that represents your project ID. It should be seen on your terminal, and the font should be in a yellow color. Now that tells you that you've actually set up the context for your commands in your Cloud Shell to run against your project, which is the one QuickLab set up for you. So if you don't see something like this, then obviously something is wrong and you need to run gcloud config set project, copy this name here and paste that there. Okay, so you can list the active account name with this command. The output will be this. Then you can list the project ID with this command, config list project. And this will be the expected output. So the fourth step, we're supposed to clone a repository. So let's do that. Let's clone that. And while that is cloning, we will change into that directory that we are about cloning and then list its content. So let's click on this. Okay, so paste it in here and then hit enter to have the second one run, the second command run. So you can see in this directory, we have cleanup.sha, we have deployments folder. This is a file. That's why it's just a gray or white, while the others are blue. These are all directories, TLS, services, pods, nginx, okay? All right, so okay, of course, that's what we saw, the file and the other directories. Okay, so now let us start a Kubernetes cluster. First of all, we want to set the zone to US Central A. So we use the gcloud config set compute /zone to set that. So advise you to type it so that you get very familiar with the commands. I seem to have a problem with my terminal. It's not presenting the way it should. Okay, gcloud. Oh God. All right, sorry. gcloud config set compute. Oh, something has happened. Okay, nothing has happened. So let's clean that up. Compute E/zone, and we have US Central 1A. Okay. All right, so we've updated that, and that's the command we were supposed to run. Config set the zone. Okay, so we are telling a G Cloud that we want every command run in the shell to be run with a default zone of US Central 1A. Okay, so we are going to create a cluster. Now, when you run this, it makes it easy on you in the sense that you don't need to set the zone when you run the command. But if you want to create something, a resource in another zone, then you need to pass the zone argument to the command. But for now, we're working with the US Central 1A zone. So since we have set it here, we don't need to set it subsequently. Okay, so let's create a cluster and paste that in and it runs. Okay, and let's look at the command again. We are creating a cluster called Bootcamp with 5 initial nodes, and we're giving it permission to our storage, read and write permission to the storage, as you can see here. Read and write permissions to the storage. Read and write permissions to the storage, and that makes it such that the cluster can have access to our Google Cloud storage, and the scope is read and write to that storage. Okay, let's go back here. Okay, still working. Okay, so let me pause this a bit. When it's done, I'll be back. Okay, so we're back. The cluster has been created, and then we need to check our progress. Okay, so that went well. Okay, the next thing we need to do is to check the version. Okay, we'll do this, check the version. So kubectl version is 1.18.5. All right, so then we use the kubectl cluster info to find out more about the cluster. Use that command to find out more. Let's paste that in here. Okay, so let me lift this one up a bit. Okay, it tells us which is the master, the IP address on which it's running, metric server, kubedns, and the rest of that. So, okay, so let's set up auto completion by clicking on that. Okay, with that now, oh, sorry about that. Return this here. Okay, with this command run, we can use our tab keys to produce this result. So let's try that out and see what happens. Okay, so kubectl tab. Okay, see, it gives you lots of options. You can pick any from there. If you're not, if you don't readily remember any of the commands, you can pick one from there. And then tab again if there are other options that can be attached to that command. Okay, so run and deploy a container. All right, so we use this command kubectl to run nginx image in one of our nodes. But there's a problem with that command. Now you run this, that's fine, that will work. Do get pods, you will get a pod, but when you come to exposing a pod, you'll not have issues. That's because the run command doesn't really create a deployment, it just creates a pod. I think there was notice about that some time back, and I think that functionality has been removed. So what we will do here, rather than run, we will create a deployment. Okay, so you copy that manually, not by clicking this button. Run it manually, or you type, whichever one. Sorry, what did I do? All right, okay, so let me clean that one out. I paste that, and then instead of running, okay, don't worry, we'll fix that. I'm having issues with my It's crazy, believe me. Okay, so instead of doing that, I'm having issues with my terminal. It's not displaying properly. Okay, so instead of doing that, we say kubectl um, create, sorry, create, I think I got that wrong. Oh, something is wrong. Okay. Oh, no. Create nginx and then image is nginx version 1.100. Okay, I think I still have issues here. This command is wrong. Okay. Oh, still did it wrong. You know what? Let me just wipe this out. Completely kubectl creates nginx, sorry, image nginx 1.10.0. Okay, we hit enter. Kubectl. Okay, I got that command wrong. Let me do that one more time. Kubectl creates nginx image. Go to nginx 1.10.0. Oh gosh, what's the problem? Image unknown flag. Okay, let me check that command once more. Run it. Kubectl nginx run create. Oh, sorry, create deployment, not just create. Sorry. Okay. Kubectl create deployment nginx image. Okay, nginx 1.10.0. Okay, so that has been created. So rather than run this command, as you see here, we create a deployment and we don't just run a pod. Okay, if you run this pod, then you will not be able to do this, and every other thing will not work as you expect it to. So this should work now. So let's see the pod that was created. Okay, we paste that in. Okay, so that's the pod. Okay, the next thing we're asked to expose the pod using service, create a service of type load balancer. So we do that, we paste that in and hit enter. And that has been exposed. Then if you run get services, you will now see the one we created here of type load balancer and the one that comes default with Kubernetes. Okay, so step 5, we now scale. Scaling here simply, we're reducing the number from 5, which we initially started with, to make the just 3. So we do that, and that has been scaled. So we now have just 3 nodes. Okay, so not nodes, sorry, pods. We use that to reduce the number of pods to 3, although we still have 5 nodes running. Try that, see what happens. Kubectl get nodes. All right, so it's still 5, but if we do kubectl get pods, we should get 3. So just 3 pods deployed to 5 nodes. Okay. All right. So of course, get pods. We've done that already. Get services. We've done that. Should we? Okay, let's get services because we need to see the IP address. Okay, so we need this external IP here because we'll be using that. Notice once you select something in the terminal, the GCP console automatically copies that to your clipboard. Okay, so we're supposed to run the curl command port 80. Use the external IP address of the curl command to test your demo application. So let's see if we can hit that. So have curl HTTP, all right, IP on port 80. All right, so we have an output. It brings in the scripts, the page, application, the main page of application, and breaks it in. So that's working fine. Okay, so let's clean up, we'll delete our deployment. Paste that in, delete that, just a second, less than a second. Then we delete the service. Remember, we created a deployment and we created a service. So if you delete the deployment, the service will still be running. How that affects the service, I haven't tested that. But if you wanted to delete both of them, then deleting the cluster would have deleted both of them automatically. Okay, so let's investigate pods in more details. Creating pods. Explain. Explore the built-in pod documentation using the kubectl explain command. Okay, this gives you more detail. The pods, fields, of course, kind pod version 1, description fields. You have the kind field API, version, metadata, spec, and status. Okay. Okay. Step 2, let's cut the monolith.yaml manifest file and see what it has. Okay, so you can see it's manifest for a pod. The name is monolith, labels app monolith, key of app and value of monolith, specifications is container called this, the image is this, arguments that we passed to the container, this, secrets, ports, port 80, container port this, HTTP health port is this, and the rest of them. The resources limits 0.2, CPU usage, memory 10 megabytes. Okay, so use the kubectl explain command with the .spec option to view more information about API objects. Okay, let's do that and see. So it gives us even more information. Okay, all right. There's a lot more than we saw before. We have environmental variable, environmental field, image group policy, life cycle, liveness, probe, name, ports, readiness, probe. Okay. Okay, so what next? Now let's create that resource on running the command. Okay, so do that very fast. Give it a minute or so before you click on check my progress. All right. Okay, let's do that. Okay, so that went well. Pods. Okay, so we created more pods. Now let's see the number of pods we have in addition to 3 we had created previously. All right, so okay, sorry, we deleted that one, so we just have 1 pod running. Now, when the pod is running, use the kubectl describe command to get more information about a running pod. So this actually will give you more information about the state and the condition of your pod. Okay, so these are the events that occurred when the pod was being set up. True, initialize, ready, continuous, ready, true, status, optional one. Just a lot basic information about detailed information about the pod we just created. Okay, you see a lot of information about the monolith pod, including the pod IP address and event log. This information will be useful when troubleshooting. It's time for a quick knowledge check. Answer the following questions about monolith pod. What is the pod IP address? What node is the pod running on? Which containers are running in the pod? Which labels are attached to the pod? Which arguments are set on the container? Okay, so that's what is the pod IP address. Okay, let's look through and see if we can find it from all this. Okay, let's go to the top. Okay, so that's the IP address of the pod. Okay, all right. Next one says, which node is the pod running on? Okay, which node is it running on? Okay, let's look through. Okay, that's the node it's running on. There, that's the node. Then the next one is which containers are running in the pod. What are the containers that are running in that pod? There you go, that's the container. It's a Docker container. This is the image ID, the pods, and the rest of them. So which labels are attached to the pod? Let's look for label. There you go. That's the label for that pod. Which arguments are set on the container? Okay, you come down here. These are the arguments that are set on the container. Okay, so okay, those answers. Those answer questions or answer the questions we've been asked. Okay, as you can see, Kubernetes makes it easy to create pods by describing them in configuration files and to view information about them when they are running. At this point, you can create all the pods your deployment requires, interacting with pods. Okay, pods are located at a private IP address by default that cannot be reached outside of the cluster. Use the kubectl port forwarding command to map a local port to a port inside the monolith pod. Use two terminals, one to run the kubectl port forwarding command and the other to issue curl command. Okay, so let's start up a new terminal because we'll be running the port forwarding command in one, and that makes it possible for us to access the container from our terminal, because we're going to map a port from our machine to a port inside the container. So when we make requests against that port in our machine, that will be forwarded to the port inside the container. Okay, so step 2, we will map port 10,008 from our host as our system, 10,080 from our system to port 80 inside the container. So let's do that. Now let's do that in the first terminal. Let's drop that there. And okay, so port forwarding is occurring. Let's go back here and then curl. Remember, localhost, port 10,080, that should be forwarded to our port. Okay, so let's hit that. And it returns hello message. So we're actually doing what we ought to be doing. Okay, so let's do the next one, which is try to access secure area in our port. Okay, authorization in our port, authorization failed. Then let's do a login. So they said we should log in to get an auth token from Monolith. Okay, so let's paste that one there. Enter host password for user. Okay, let's see what we're supposed to do. Logging in causes a JWT token to be printed out. You use it to test your secure endpoint with curl. Okay, so we're told what we're supposed to do. All right, so at the prompt, enter the password as password to sign in. Okay, so it's asking for password, and the password, of course, is password. Okay, in Linux, when you enter a password, it's not shown to you. Unlike in Windows, when you type, you see it. In Linux, you won't see it. You simply type it in the terminal, and it does its business in the background without you seeing. So that token has been generated. Okay. All right. Cloud Shell doesn't handle copying long strings well. So copy the token into an environmental variable. So the same token we actually generated here, we're going to pass that into a token variable. That is this one here. All right, so let's click on that. Click on and paste it in here and hit enter. Okay, so we put our password again. So that has been collected. All right, so at login prompt, enter password to sign in, of course, access the secure endpoint again, and this time include the auth token. Okay, we run a curl command this time to that. Let's do that. Okay, so it goes through. We are able to get to the secure endpoint and get the result of message hello. Okay. All right, so use kubectl to see the logs. Let's see what we have done with our pod. Okay, so those are the actions we've carried out on our pod. So that's a good way for you to find out what commands we run and the activities that have been going on in the pod. So for us to follow log events on our monolith pod, we can pass the F argument to the logs command, and that will create, that will follow every action carried out against that pod in real time. Okay, that gives you a chance to see what is actually going on in real time. Okay, so all right, so I think we're supposed to close terminal 1. Okay, let me go back to terminal 1. If I do that, then this port won't work. So, okay. All right, so let's open a third terminal. I think we're supposed to do that. It says here, you see logs in update in terminal 3. So let's open okay, I think I missed something there. Okay, that's the one there. It's okay. To create a third terminal, click this, and then, okay, so we actually did this in the second terminal instead of the third terminal. So use curl in terminal 1 to interact with monolith, and you'll see logs update in terminal 3. Okay, so we should see things change here. Now notice the last entry here says curl /7.640. Okay, let's go back. Let's do that here. I'll paste that here and then hit. All right, so go back here. All right, the same value, but you see the numbers have increased. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 lines there. Let's do that again. Okay, let's count the lines this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So one more line has been added. So that's what the F flag does for you when you pass it to the log command in kubectl. Okay, so let's use kubectl execute exec command to run an interactive shell inside the monolith pod. Okay, so we're going to go into the monolith pod. Let's do that here. Let's hit that. Okay. All right. I noticed someone asked this question. I said the deprecated warning was shown. Actually, yes, that's because this format of the command is deprecated and you're expected to use this other one. So let me exit out of here and show you and run the other command the way it should be run. Okay, so after exit, we have dash dash and then space. Wow, problem with this stuff. My terminal isn't working the way I expect it to work. And so I'm having difficulties. Okay. All right, dash dash dash. Let's hope I got that one right. Okay. All right, I think I did something wrong there. Okay, let's look at this again. Okay, the actual command, tty command. Okay, let me look at that once more. Okay, when it executes, pod is this, and okay. Oh gosh, this thing is all right. All right, so that works. All right, so the whole of this actually should be from here up. Okay, and then pass the double hyphen, then the command, and the command here is /, so we're there. What else are we expected to do? We're supposed to ping Google from inside the container. Okay, so let's do that. Okay, and the ping works well. So we're actually inside the container. Then we exit. Before we exit, let's run list command and you will see. Okay, so basically these are the things you will see in a Linux system. So we're actually inside a Linux container. So let's exit out there from there. All right. Okay, so to quit the port forwarding, you press Control C. So let's do that. Let's go here and then Control C and we're out. And of course, let's stop this one too. And we're through that. Monitoring and health checks. Now, Kubernetes supports monitoring applications in the form of readiness and liveness probes. Health checks can be performed on each container in a pod. Readiness probes indicate when a pod is ready to serve traffic. Liveness probes indicate whether a container is alive. If a liveness probe fails multiple times, the container is restarted. Liveness probes that continue to fail cause a pod to enter a crash loop. If a readiness check fails, the container is marked as not ready and is removed from any load balancers. Okay, so liveness checks if the container is alive, while readiness probes indicates when a pod is ready to serve traffic. So a pod could be alive, but it's not ready. And of course, a pod that isn't alive can never be ready. Okay, in this lab, you deploy a new pod named Healthy Monolith, which is largely based on the monolith pod with the addition of readiness and liveness probes. In this lab, you will learn how to create pods with readiness and liveness probes, troubleshoot failing readiness and liveness probes, creating pods with liveness and readiness probes. So let's let's see what the file contains. Okay, no file or such directory. First thing first, let's run a list command. I think that should be in here. So Oh, okay. Let me go out. Let me start from. Okay, first of all, we're supposed to do this. Okay. And it didn't work. Okay, that won't work because we're not in the directory, but if we're here, it would work because that file is found in the orchestrate with Kubernetes / Kubernetes. So if you do the list here, okay, so you see pods is here. So if you're running it from here, you actually need to go into the Kubernetes folder and then into the if you're running it from here, you need to go into the orchestrate with Kubernetes folder and then change also into the Kubernetes folder. When you do that, it runs. Okay, so let's do that from here. Of course, we see what we need to see. That's a manifest for the new deployment we want to make, new pod we want to create. Okay, so let's create a pod. We'll run this command and create a pod. Okay, that will take less than a second. Then we check out progress. Okay, it works. All right, so pods are not marked ready until the readiness probe returns an HTTP 200 response. So use kubectl describe to command to view details for the healthy monolith pod. Okay, let's see what that will do for us. Okay, so okay. Now see how Kubernetes responds to failed. First of all, let's check. Okay, it's ready, status, initialize ready, container ready. So it's all ready from what we see here. Okay, so see how Kubernetes responds to failed readiness probes. The monolith container supports the ability to force failures of its readiness and liveness probes. Supports ability. This enables you to simulate failures. So we're going to simulate failures. We're going to run the same forwarding command. And then let's do that from this terminal. Okay. Okay, so when we hit port 10,081, it directs it to port 81. Now remember, if I'm not mistaken, we have 2 ports running. So let's check that. Let's check that, get ports. All right, so we have 2 ports running. One is on port 80. The other one, new one we just created, is running on port 81. So for us to be able to do this port forwarding properly, to be able to access the new pod we just, that is healthy monolith, we need to use port 81, and of course port 10,080 is already taken, is in use, so we need to just change the port and it should work fine. So that's what was done here. Okay, so now we curl the port just like we did the last time. Let's do that here in this terminal. All right. Okay, so nothing's coming up. Said force to fail. Use the curl command in this toggle readiness probe status. Note that this command does not show any output. Get the status of the healthy monolith pod using the kubectl get pods with the W option. Okay, so let's see what happens. Okay, so actually the W option waits on the pod, gets the pod, but it waits. It doesn't close the terminal, doesn't return the terminal back to you. It holds on to the terminal and keeps running the get pods command on that pod. Okay, so okay. All right, so press Control C when there are 01 ready containers. Use the kubectl describe command to get more details about the failing readiness probe. Okay, so let's first of all select this one, come back here. Nothing is really happening. We need to wait until the pod fails. Okay, so I can just Control C and run that again. All right, so it has failed. So let's come here and then paste that, and then let's check out. Let's go up. Okay, you can see readiness false, container ready false. So the container isn't ready. It's been initialized true, readiness false. So all right, so that worked out. Okay. To force the monolith container readiness probe to pass, toggle the readiness probe starts by using the curl command once more. Okay, so we go back here. But forwarding is going on. Okay, so let's do that here. We hit that, and of course, something should change. All right, so wait about 15 seconds and get the status of the healthy monolith pod using the kubectl get pods command. All right, so something has changed. Okay, so we should wait about 15 seconds. So let's wait a bit. Okay, meanwhile, when 15 seconds has elapsed, we will run this command, and then after that, we shut down everything before we do the last one. Okay, so back here, it's changed. I think it's all 50 seconds. Let's cut that out. Let's remove the option. The pod is back up. And of course, if you do describe once again, come up here, see it's now true, initialize true, readiness ready true, container ready true. So the pod is back to good health. Okay, so press Ctrl C in terminal 2 to close kubectl proxy as the pod forwarding. Okay, that was done here. We will simply just cancel out and close one of these terminals. And then let's do liveness probes. Building on what you learned in the previous tutorial, use the kubectl forwarding and curl commands to force the monolith container liveness probe to fail. Observe how Kubernetes responds to failing liveness probes. Okay, so let's go back up here. I think we read something. I can find it. Okay. So if a liveness probe fails multiple times, the container is restarted. Okay. So liveness probes that continue to fail cause a pod to enter a crash loop. If a readiness check fails, the container is marked as not ready and is removed from any load balance. So liveness, constant liveness failures leads to a pod being recreated. Okay. Restarted. But if the readiness probe fails consistently, then the pod will be removed from any load balances that it might have been attached to. Okay, so let's go down. Okay, let's go up a bit. Okay, we're here. Okay, so use kubes forwarding to a local port to the health pod, healthy monolith pod in terminal 2. Okay, so we are doing the same thing we did before. I would prefer to use this to do that. Okay, so we're doing port forwarding once more. Now we force it to have liveness failure. Okay, so we do that here, and that has happened. Then we watch to see the changes that will occur. All right, so when a liveness probe fails, the container is restarted. Once restarted, the healthy monolith pod should return to a healthy state. Press Ctrl C to exit the command when the pod restarts. Note the restart count. Okay. Okay. Open a new terminal here. I was watching this here, still watching. Open this terminal. All right. Okay, so, all right, so let me do this here. So that's what's happening. Schedule, pulling, pulled, unhealthy, created, started, unhealthy, killing, pulled. Okay. All right. So killed it and pulled it again. So, all right. So something is happening here. Let's cut this and just run it one more time. Okay. So it's back. All right. All right. True, false, false. It's not yet ready. All right. Let's hit it again. All right. Come up here. Oh, it's back up. So, okay, so it's been pulled and it's back, normal pulled. So those are the major differences. When a liveliness probe fails, port is restarted, but if its readiness keeps failing, it is removed from any load balancers and it's not recreated. Okay, all right, so we're through with this lab, and of course, you can now close this. To ask you to confirm, click on leave page, and then click on that to end your lab. Whoa, 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 whoa. All right, submit. Yeah, made a mistake. We didn't check our progress. So 15, should have been 20. I don't know if you have any other one we left out. It's all right. You can always redo it and get to that point. Gives you an opportunity to learn more. Okay, so that's the end of that lab. Thank you for watching. Please click the like button if it was very helpful to you. Thank you.